Okay, hi everybody. My name is Kaija, and today I'm going to be presenting the Programming with ggplot2 chapter of the ggplot2 book. So I've got it up here. We're going to talk about how you can use ggplot2 to do more automated things than to just create each single plot manually on its own, which is especially useful when you need to make a whole bunch of the same plot or make a bunch of very similar plots, and you want your code to be more efficient than just having to program each of them in general. Okay, so why program with ggplot2? So to reduce duplicated code, to build up repeated components. Those repeated components can be like really all the same, or they can be much more generalized to allow for flexibility. And the chapter sort of illustrates how there's trade-offs between those two things, like efficiency and flexibility, which I think is always the case when you're writing functions. And so to start with, it helps us to recognize that the components of a ggplot2 plot are objects in and of themselves. So like when we make a plot, we go layer by layer, and we use the plus sign to add additional layers, and each of those layers is actually an object. So here's an example. We can create a new object and call it something arbitrary, in this case best fit, and assign it to this geom_smooth object, which we give several parameters. We give it a color, we give it, linear model per the method. And I just put class of best fit here to indicate that, to like show you all that this has multiple different types. It's like a ggproto object, it's a gg object, it's a layer instance. I don't really know what all of those things are, but it does work to assign it to a variable name, and then that implies that you can then use that in the same way that you would use other variables. And so we'll see how that can be added on. Side note, I thought this was interesting. I had never known about this alpha function. So you can actually do alpha and then, a color and then the alpha, and it will output the hex code for that color at that alpha level. So like it's the extended hex code that includes the transparency. So I thought that was a really neat thing to know. Okay, so we created that best fit object, and now instead of typing out geom_smooth with all its specifications on this ggplot object, we can simply add the best fit object directly as if it were another layer, because that's what it is. It is another layer. So we create the rest of our plot, and then we add best fit instead of typing that all out, and it adds a best fit line, and it pays attention to the data that we used for the rest of the plot as well. So another thing we can do is to build a layer using a function, and that's important because you might not always want the layer to be exactly the same. You might want to change some things about it. So in this case, we create a function called geom_lm, and we give it a couple different arguments. We know that we might want the formula to change. And here the person writing this function has provided a default formula of y tilde x, which will just give us like a linear fit. But then we also have the color, which again has this default of the steel blue, but then you could put something else in if you wanted to, and a default line width of 2. And then importantly, they also talk about highlighting this ... operator, which allows you to pass other arguments into the function that can then be used in other places. This has always confused me, but I think this chapter kind of helped me understand a little bit how this works. So they use the example of they put ... here, and then they also put ... in the geom_smooth call that's inside this geom_lm function, which means that if you want to put in other stuff, other arguments to geom_smooth, you can do so. If you didn't have the ... basically, like if you have a function with only a fixed number of arguments, then you can't just decide to put in another argument to that function, because it will not understand what you're talking about. If you try to give it, if you have arguments x and arguments y, and then you try to say like z equals such and such, it will not be able to make sense of that. So the ... allows you to pass in some arbitrary argument that might be needed for other things deeper in the function. And I think that's a really important thing to pay attention to. They give an example here. So we create a plot with MPG, we set the aesthetic mapping, and then we use geom_lm, and here we're specifying a different formula. Instead of just y tilde x, we've decided to use a polynomial, like a quadratic function. And here we can override the default line width of 2 and just say use 1 instead, and then color equals red to override the default steel blue. And then I have I have a slide, I guess, on the ... So, right, like I said, allows it to accept additional arbitrary arguments. I had a little bit of trouble coming up with an example of this being important, and I think if I had had more time, I would have spent more time on this, but I looked at the documentation for geom smooth, and I noticed that there was an na.rm argument that you could pass to geom smooth, and so I just went ahead and passed that to geom_lm, which again, if we go back, we didn't define, there was no argument here for na.rm, and there also wasn't any argument here for na.rm, but because we use the ... it means that as long as the argument is valid to be passed to that function, the function will allow it to be
So could it be like, for example, alpha? I know that making a line a little bit see-through doesn't make much sense sometimes, but an alpha could be also there, right? Because alpha is already defined outside.
Exactly. I think it could. So like any other arguments that you'd ordinarily be able to put into geom smooth if you were using it alone, you would also be able to put into this new geom_lm function, which it can be really helpful. And here the na.rm doesn't actually do anything because I think the data set doesn't have any NAs. So again, I should put in, maybe I could use alpha as a better example here. Okay, so then I did some of these exercises. I didn't do all the ones in the chapter, but I did this section because I wanted the practice and I figured I could show it. So create an object that represents a pink histogram with 100 bins. I interpreted this as like this. So I made an object called pink hist, which was just the geom histogram portion of a plot. And I specified that I wanted the fill to be pink and that the number of bins should be 100. And then I went ahead and added that to this ggplot of diamonds. And instead of adding a line that says geom histogram, I just added pink hist directly. And then I added some labels as well. So that's what we get. Whoops, my formatting is a little wonky here. Create an object that represents a fill scale with the blues color brewer palette. So again, I used scale fill brewer to create this new object called blues fill scale. And then I initialized a plot with the diamonds data, and then I added the blues fill scale to the end of the plot as well, and this is what we get. I also, let's see. Okay. Then it says read the source code for theme gray. What are its arguments? How does it work? This one, the source code is huge. So I typed in theme gray. Side note, if anyone didn't already know, you can type in the name of a function without the parentheses to actually see the function itself instead of using the function, calling the function. So this is what it looks like. It's huge. We're not going to read through all of it, obviously. But I noticed that the function takes some base sizes as arguments, and it has defaults. And then I think what they were trying to get us to learn here is that it uses the same principle of like creating a theme object and assigning it to a variable t. This giant thing with all the specifications is exactly the same as if you added theme to a plot and you started putting in your own specifications, except here they're assigning that to t. And then the other thing that they do at the end is this thing. So I didn't totally understand what was happening here. But I think, so they have this like fancy percent plus replace percent thing. And I think basically what's happening here is they're saying take the theme portion of the plot and replace it with this T object that we've just created. I probably should have dived down. Like, I don't really know what this, actually, let's go to our studio here and investigate. Of course, I've now lost the window. Unhelpful. Okay. So here we are. Sorry, I totally should have kept this open. File. There we go. Okay, so some spaces. Okay, so we said theme gray. Okay. So what I want to know is, what is that? Ready to go? Okay. ggplot global. So yeah, this isn't some magical thing that exists. I guess what this, yeah, so this reinforces, I think like this must be the current plot that you are dealing with, because you'll be adding this theme gray object to whatever current plot you're already working with. So the fact that ggplot global isn't just something that exists already from the package or something, but is something that, you know, must exist when you use this theme, I think means that it takes whatever the theme is for that plot. That's my best interpretation. I don't know. Did you have any other, like, yeah, interpretation of that? I think that's probably what's happening.
The only thing that I could find here is in GitHub, and it only says that it's an internal implementation detail that shouldn't be exposed.
Yeah.
So it's just for them to set the global theme, I suppose, for all plots. So don't even worry about it. I'll put it in the chat just so that you can have it.
Yeah, definitely not. I don't think it's something that we should be pulling out and using. I just was curious, like, what was going on here. Okay, cool. So sharing. Okay, and then the last exercise was to create a scale color Wes Anderson. It should have a parameter to pick the palette from the Wes Anderson package and either a continuous or discrete scale. So we had to load library Wes Anderson, and then I made this scale color Wes Anderson function where it has a required argument palette and then an argument for type, and I use the ... so that if you wanted to include any other arguments that you would normally put into Wes palette or into scale color manual, you could do that. I wasn't sure here. So do you think this is needed? Did I do this right? Did I do this wrong? I think I'm still really fuzzy on the ... Like, what if you wanted to put other arguments into here? Maybe you can't. I'm thinking now that this is incorrect. I'm thinking maybe you can only have one ... which indicates where the extra arguments get put. Does that sound right?
I think it's so I don't know if you need it there because the only extra arguments that you're gonna put are in your function.
Yeah.
Do you need them for the other ones?
Well, no. So I guess what I was thinking is like, what if you wanted to specify an argument, another argument to Wes palette, but then what if instead you wanted to specify another argument to scale color manual that isn't an argument to Wes palette? And I think I'm realizing as I type this, I wrote this and then I only tested it by specifying another argument to Wes palette. I didn't also test this external one, so I suspect it would break. Or it would cause confusion. And I think maybe I'm now understanding the ... that like you can only have one because it then tells R like where does it put the extra stuff? Does it put it here or does it put it here? And it's not gonna like know which one. So I think this is wrong, but it worked here at least. Where I did scale color Wes Anderson palette equals Cavalcanti one, and then the default was type equals discrete, but I could have also put continuous. And we get this, which is, you know, a little ugly, but worked. Cool. So, oh, and I did not get the new heading here. But so since we already talked about a ggplot plot is an object, it's also a list. And each layer is, as we saw, each layer is an object. So the entire ggplot object is a list of several components. So that means that if we want to add more than one component, we can add those components as a list. Here's an example, geomean, where we have a list where we add two different stat summaries. One of these is for the error bars, and then one of these is for the actual geom bar. So if we add that to a very simple ggplot call where all that we specified was MPG and the aesthetics, and then we add geomean, lo and behold, we've added not only our bars themselves, but also the error bars to go on top of them. Not a big fan of this type of plot in general, but it does illustrate the point.
I wonder if this is the same as if you were to use an if-else argument in the function, because I've seen that if your geom is bar, what was it? If your geom equals bar, then do this, else do that. Because I've seen that inside functions.
Yeah, I think you could do that.
I guess it's the same thing, right? It sounds like it's the same thing.
I don't think this is the same thing because here the list has two components and it's adding both of them, not one or the other. It's adding both the bar and the error bars.
Well, I guess you only have two options, right? Yeah.
Well, it's not, they're not options. It's like both of them are like, they're both happening at the same time. So it's sort of equivalent. I think this would be equivalent to doing ggplot plus stat summary plus stat summary. Like there's two different stat summaries in the same plot.
I get it. Okay, I see what you're trying to do.
But like I think what you're saying is also true that you can have if else in your function. And another thing that they noted in the chapter that I didn't put in the slides and probably should have included is that if there's a list element that's null, it will just be ignored. So if you were to use if else, you could do something like, you know, if such and such variable, then stat summary else null. And if it ended up just adding, I don't know, like if you did something silly like if the data set is MPG, then add these bars, otherwise make this layer null, but like still use this one or something. I don't know. I'm not sure why you would do that, but then you would have a list of null, comma, stat summary effectively. Or in a more extreme case, if you had if else's on both, you could have a list of null, null. And when you added geomean, if geomean was just null, null, that's fine. It would just return this only. And that actually reminds me of another trick that I'm not sure if we talked about before, which is when you're making a plot layer by layer. So for example, this has nothing to do with the if else, but just ggplot mpg aes class. Oops. Yeah, okay. All right, so let's say we do what? Okay, so let's say we do that. And then we do like theme classic, plus scale, plus, I don't know, labs, y equals city, class, so something like that. But then, let's say I decide actually I don't want those labels at all. So I can comment that out, which I do pretty frequently when I'm working in ggplot. But then this code is not going to run because it ends in a plus sign. It's just going to be like, wait, what? You either get an error or it gives you a plus sign that just expects something different. So if you're in a situation where you're making a really big plot and you know you're going to be adding a whole bunch of layers and maybe experimenting with different ones and maybe commenting out some of the layers to test it out, it can be good practice to end your entire plot with null like that, because then you can comment out any layer and this will still work because it goes plus null. This has nothing to do with the chapter, but it's useful. I do it all the time. I wouldn't recommend it it doesn't hurt anything, so you could, but like, I don't think you need it for final code. But when I'm just messing around with the plot and commenting out layers and removing layers, it's annoying to have to keep typing the plus sign over and over again. So yeah. Okay, back to the chapter. All right. So I also liked that it reminded us that there are many components of a plot and they're all objects. So we've been seeing that layers can be added with assigning them to variables and then adding them to the plot. But the data frame that goes into the plot is also an object. The AES specification is also an object. The scales are objects. The coordinate systems are objects. The theme components, those are all objects. So you could add those as variables as well. And here's where I got a little stuck, but I'm hoping we can work this out together. They pointed out that you could use the percent plus percent, or that you need to use percent plus percent if you're going to substitute in a different data set instead of just plus, because I'm not sure why, but if you're going to override the data set, you've got to use that. It doesn't, if you're going to override the different, if you're going to override the aesthetic or like the scales or something, you don't need that, but only for data sets. And they did not expand on that in the chapter, so I decided to explore a little bit. So I created this one data set where we have 3 individuals, each with a normal distribution with a slightly different mean. And then a second data set where we have the same 3 individuals, but now it has a Poisson distribution. So I just wanted there to be like visual distinction between the two. So we got data set 1, data set 2. We can first create a plot from data set 1, and it looks like this. 3 different individuals, different means from a normal distribution. And then if we use this code to take our plot 1 and then do percent plus percent data set 2, what that does is it replaces the data set in P1 with this new data set. But it keeps all the other code the same. So it would be equivalent to just substituting in data set 2 into here. And if we do that, sure enough, we get this plot where all the specifications are the same, except the curves have moved because now it's a different data set that contains different stuff in it. Does that make sense?
How does it know that it's the data set that needs to be replaced?
Because of this.
So that is telling it it's going to be the data, whatever it is. This could be named, I don't know, opossum 2. It doesn't matter what it's named. It knows that it's going to be the data set.
Yeah. And that's why you use the percent plus percent. So it is handy, except it was occurring to me like that only is going to work if you have the same variable names. Like I had ID and I had value, which matched ID and value here. So then I was like, well, what if the data set doesn't have the same variables? And here's where I really got stuck. I created a new data set 3, where instead of value, this column is called test. And these are still Poisson distributions, but I changed the lambdas to 4, 5, and 6, so we'd have some visual differences here. And so I naively was just like, all right, well, or, deliberately naively, I was like, all right, I can just use that same operator to replace data set 1 with data set 3. But it doesn't work as expected because there's no value column. And here we have a test column instead. And it's expecting value because the original code to create P1 had this aesthetic in it. And then I was like, okay, well, they told us in this part that the AES specification was also an object. So shouldn't I be able to put in a new AES to override the old one? But it didn't work. So I tried this. I tried making a new aesthetic which had y equals test instead of y equals value, leaving the x the same. Maybe I needed to also specify the x, possibly. So I'll try that in a moment. And then I tried first putting this in with a regular old plus sign, and then putting this in with the special plus sign to indicate that you're replacing the data set. And it didn't work. It gave me what I think is just the original P1. So, but it also didn't give an error, which I thought was kind of interesting. Because remember, if I just took P1 and then tried to substitute dataset 3, it gave me an error. But here, no error, but it just ignored the new dataset and used the original one. So I don't know what's happening here. And I don't really know how you would use a different data set in most cases. Like in most cases, the data set, if you want a different data set, it might have some differences. And I guess the only place where I could see this being useful is if you had a bunch of data sets that were all exactly the same except for the values, and you wanted to add in, like to substitute in those new data sets. But as we're going to see in a little while, I think making a function would probably be a more efficient way to do that anyway. So I kind of didn't go down this rabbit hole very much farther, but I would be interested in further investigating what the heck is going on here and why this doesn't work, because I thought it should work. All right. So annotations, I didn't go super into this part, but they were talking about how you could add annotations to your plot, and if you do that, make sure to not have it inherit the aesthetics, because your annotations probably are going to have their own aesthetic mappings that allow them to work. And then also show.legend equals false, so that your legend will remain the same for the original plot, and the annotation won't be added to the legend. They give this example of a function called borders, where you grab, you use this map data function to grab from whatever database is specified here, whatever regions are specified, and then you can draw polygons of those regions. And then they give the example of using that to add to a plot that you've already made here with the data from capitals, which is US capitals, and add on here the world borders. So that's a thing that you can do. And because we had the inherit.aes equals false, it didn't force the same long lat. Although now that I'm looking at it, like presumably, yeah, okay, I think I don't really understand this part very well, because like, what is the tilde here? Why is it AES underscore? I don't really know what's happening in this section. But takeaway, these are important. And I use inherit.aes all the time. I use it for like geom text. If I need to place the text on particular places and maybe the names of the X and Y columns are different or something like that.
So the inherit AS, can we go back to the previous one? So the inherit AS, can you go scroll down, because you did this part a little fast. So the inherit AS, so I've never used that function. So that is so that whatever you put in the first part doesn't go into the following functions.
Right. So remember when we talked about layers and how, and you can use this outside of annotations too, like if you're just making a plot, when we talked about plot layers, that like the first layer comes first,
yeah,
and the second layer comes second, and if you specified the AES in the first layer, the second one will automatically know to use the same X and Y or the same colors, for instance. Or whatever else you put in the AES. But if you wanted to add like a set, like maybe an annotation with a completely different data set where instead of the columns being called X and Y, they're called long and lat, or they're called, capital X and capital Y, or maybe the color needs to be mapped to a different variable than the one that you were using before, you don't want it to inherit the aesthetics from the previous layers.
Okay. So it doesn't give it to the following layers, I suppose. Yeah. Those aesthetics stay inside the geom polygon right now. Okay. Yeah, right, that makes sense. I've never used that one because I specify the aesthetics for each one. I mean, if I'm going to use different aesthetics, I just specify them for each one. But I guess this, it makes it less, so that your function can be less verbose or something.
I guess so. I didn't really understand this part. I think I probably didn't explain it well, but it's the kind of thing where I'm sure I'm going to come back to it at some point and be like, oh, that's what they were talking about. So, yeah.
Because I didn't even see any annotations there, I suppose.
Well, what was the annotation? The annotation was the borders that you were adding on in that case. Oh. But I agree that was a really confusing way to explain it, I think. Okay, well, anyway, continue. I was also super confused about this part, honestly. Additional arguments. So I directly quoted from the chapter because I was really confused. If you want to pass additional arguments to the components in your function, ... is no good. There's no way to direct different arguments to different components. Instead, you'll have to think about how you want your function to work, balancing the benefits of having one function that does it all versus the cost of having a complex function that's harder to understand. And this is definitely something that I can relate to because I've tried to write functions before using ggplot, and I'm always like, oh, this will save me so much time. And then it ends up not saving me time because I've either made the function way too complicated or I've made the function not flexible enough. But I think now that we've talked about this part here is what we were talking about in this section, where we had the ... and then I was like, well, what if you wanted to pass different arguments to different places? And I think we decided that ... can't really do that. So here they started using modify list and do.call, and I did not follow this. I don't know what they're doing here. I read it for a while and was just really confused. So they make this function called geom_mean, and they use this ... argument so that people can pass in arbitrary arguments to the function. And then there's only one place in the function where they put the ... stuff. It goes here. So I think that's a correct use of it, right? And they create this params list. So this is all of the user-defined stuff, extra arguments. And then they I guess I don't really know what modify list means. Oh, I think maybe I'm understanding. So maybe modify list adds something to a list, because then bar params is its own list and error bar params is its own list. So we have three lists here. There's the error bar list, the bar list, and then the everything else list that the user specifies. And so here you're creating two lists, bar params and error bar params, where in both cases you've added on the user-defined parameters to each of the previously specified lists. So now you just have two. I think that's what's happening. I don't really know what modify list does, but I have to imagine that it's just putting two lists together into one list.
Yeah, I put the definition in the chat. But I think it's exactly what you just said, because if it modifies a nested list recursively, then is that because you have two lists at the beginning, bar params and error bar params. So then you want to you want to do something to each one of those.
Oh, so maybe it's like, yeah. Yeah, I guess like what, so if a thing that you specified here would override something that's already in this one.
Let's see how they used it. Because
Yeah.
you have bar, error bar also there. Okay, so did they use it? Did they use the function? Is there like an example?
So they use it here. But let's first try to read through the rest of the code. So they make the bar, they use do.call stat summary on
Yeah, that's very confusing because they are, so do call is when you want to do something to a list. I guess the
yeah.
list here is stat summary.
No, the list is this thing.
Oh yeah, you want to apply stat summary to that. Yeah.
Yeah. And so I guess, and then once again, the modify list, these are the defaults. And then bar params is what you got here that's going to override or add to this list. So
bar params,
which is this thing.
Yeah.
Which in turn is this thing plus this thing, or this thing like
I think
union.
it's a very convoluted way of writing.
Yeah, I would never do this. This seems really not worth your time to write. But it is sort of interesting to see what they're doing with it. Anyway, so here they added these parameters, width equals 0.5 and size equals 1 for the error bars. But I guess like, oh, this should be line width, but anyway. And so because we did this, okay, so I guess what we're supposed to take away from it is color equals steel blue. That
is for the
passed in by
cars.
the user. So that goes into here, which means that it ultimately makes it into both of these. So we end up with steel blue error bars and steel blue bars.
Oh, okay.
But then something like the line width, this should say line width, the size equals 1 thing only goes in the error bar params. So these
Ah,
are thick.
I think I understand now. So then when you want something applied to just a specific one of those,
Yeah, exactly.
that's why they did it like that. If not, then it goes to the dot dot dot, which is gonna be applied to everyone. Oh, okay, I think I see it. But I don't think I could write a function like that.
No, I don't think so either. It would be, yeah, it
But
seems really complicated.
it seems too complicated, but I think I understand what they're trying to do. I mean, I wish I could write functions like that.
I mean, I don't ever have a use case for this, like it's too much. So, whatever.
Data can get complicated so easily.
Yep. So moving on, we can make a function, and it could be something like a function that takes the data and takes the mapping and then uses those to create an entire plot. So for example, this function called pie chart allows you to pass in the data and pass in the entire aesthetic mapping. And notice this is a little inconvenient, so we'll be looking at a different way to do this in a minute. And it creates a pie chart. And I guess the strength here is that then you could make a pie chart out of any arbitrary data set with any arbitrary like variables and specifications here, because you could just pass in the AES as an entire like argument to the function. However, if we want to pass in other variables, it's annoying to have to pass in this entire AES thing and actually like when you're using the function write out AES factor blah blah blah. Like I don't want the user to have to remember what arguments are needed for the pie chart, or like what order to put them in or know to write the AES. Instead, I would like them to just be able to tell me which variable they'd like to use and then get it passed through to ggplot2. And this is a really common use case where you want to make a function that like makes a bar plot as long as the user passes in the X and the Y variables, which also gets at the problem we were discussing earlier with adding in a new data set. Like you want to make a plot that looks the same, has all the same theme, has the same type of plot, but you're giving it a new data set, which means that maybe you're going to be needing to refer to different columns. Or maybe you want different columns of the same data set, whatever. So instead of writing out the entire AES, we want the user to just be able to pass in the variable name. But there's a problem. If you do something like this, where you give xvar as a variable that the user can pass in, and then the user tries to pass in ABC, it's not going to properly use ABC in the aesthetic inside the function. And that's because of tidy evaluation, which is a non-standard evaluation, which I still don't fully understand and thought that this chapter was going to get into more of, but they didn't, so whatever. But it means that this is the output of running my function on ABC. The AES is going to take the expression here, the literal text xvar, and see that that is the variable that they need to use, instead of taking the value that the user specifies here for the X. So to fix that, we have to embrace the argument in these two curly braces. And so here it tells it like, no, we don't want you to literally take X underscore var as the variable. We instead want you to take whatever the user specifies as the value of that expression. So look inside the argument, use its value, not its expression, and pass in ABC. And so we can see that now if we run my function on ABC, it understands that it should set X to ABC. Does that make sense?
Yes. So tidy evaluation, I feel like I have a better grasp at it now because I have read about this like 10,000 times.
Yeah.
Still not 100% clear on it. So I put something here in the chat where I have specifically for ggplot, because there's also one for dplyr. But they explain it a little bit better. There's another one too. I'll see if I can find it and put it in the chat. But the idea is that so some of them you put in curly brackets and some of them you don't. They explain it much better in here because there is a difference. The other one, the other book, R for Data Science. Yeah, the basic book, the R for Data Science, I think it's called. That one also explains tidy. Well, it explains it for tidy, not for ggplot, but it explains the double brackets, the tidy evaluation, a little bit better. So I also recommend that one. I don't think we have time too much for this one, but,
no, we didn't.
But check this one out in your own time. I think it explains it a little bit better. But it's one of those elusive things that, I have to go back because I don't always understand it. But
I know. I get so confused and I wish they would just like make it consistent, but I understand that there's real reasons that it's not consistent. It's just, it's just confusing and I always forget. I end up having to try a bunch of different things each time.
Yeah, in my brain, when it's always there, it's like, oh, if I got an error writing a function, it's probably the double brackets. So then I'm like, let me try that first and then see if that fixes the stuff.
Right.
And then usually that's what happens.
Totally. Me too.
Yeah. Tidy evaluation. Oh my God. Yeah.
So they show how to use this with the pie chart function, where now we have data and var. And then in the fill section, we embrace the var so that it will take the value that the user passes in. This means that you can just put pie chart with the variable or with like the data piped in and the variable instead of having to write out like the entire AES factor 1 thing in your use of the function, which is very useful in case, maybe the reason that you're writing this function is because you want somebody who's less familiar with ggplot to be able to use it. and you don't want to have to explain what AES is. Or maybe you're writing it for yourself and you just want to save yourself some typing. This is super useful. And this is the sort of thing that I would use all the time, because if I'm writing a ggplot function, more often than not, the thing that's going to need to change is the variables used. Like if I want to make the same plot for a bunch of different combinations of variables, this is going to be really important. So yeah, that is all for this chapter. I actually do need to go because I have another meeting at the hour and I have to prep a little bit. So gonna call it a day here, but I think this was a really interesting one. And I want to dig a little bit more into the ... thing and try to understand what's happening with that. And then also I'm gonna test out like making some functions using this embracing to make sure that I understand it. So yeah, thanks for adding that link to understanding it more. I think that's important.
Thank you so much, Kaija. This was great as always. So I'm gonna